Hello everybody. In this video, I want to change the local in-memory database that we have for the API to actually use a real database. And one of the cool things here, I don't want to complicate things either. One of the things Cloudflare provides us and is available in the free tier is the D1 database. The D1 databases is just serverless SQL databases that pretty much like SQLite databases. If you are aware what SQLite is a database in a file. That is a lower version of SQL that you can run for, especially for a smaller application per se. That's really good through that. And it have a really low maintenance. That way that you don't need to have a really big team or a rack pointing to a SQL server or an Oracle server or any other database that you can actually provide Postgres, MySQL, whatever. But one of the cool things is they created the D1s on top of SQLite infrastructure, and then they provide the Cloudflare infrastructure to deploy those around the world. It's actually really simple, really cool way to use those. And we can have our cloud database and local database to test locally too. And that I think that's actually really, really neat. So let's actually start doing that. So the first thing here, and look at developerscloudflare.com, that D1, you can see the documentation percent. And we can go right there where it says create your D1 database to see what we need to do. We can deploy directly, or we can do this project, but we are not doing a new project. We are not doing a new worker. Worker is where we will be deploying our REST API in a worker process. The view application will be deploying those in pages. The backend application will be deploying in workers. But let's just scroll down and go directly to create a database itself. And with this command, we should be able to create a database, and we'll add this document or this part of the document in the JSON doc for a project per se. So if we move forward to, and I think I have it somewhere. Oh, I think I don't have it. Let me open it. Oh, um, there you go. Right here. Let me just expand it. If we see our JSON doc, when we created the Hono app, it gives us a bunch of predefined examples that we can use. And all those are for different elements that Cloudflare could provide. As you can see, the D1 database is right here, and that's what we'll be adding. We'll be adding a binding, and we will provide a name. And then this will be the local name in the application, like the reference that we'll be using. And after we have that particular reference, we'll be given a name, and that database name will have a specific ID. That will be a generated ID that we have that. We can do that manually, but let's actually better do it through the process of the command. So let's with D1 create. So we already have Wrangler installed globally. So we should be able to do inside our project flow folder will be just Wrangler. We don't need add latest because we already have this installed globally. D1 create. Let's say D1 create project underscore DB. And let's click enter. It will execute the Wrangler CLI. And if it would like Wrangler to add it to your in behalf, this is what we need to add it. It give me binding. Usually provide the same one. We will change the binding name and give it a database ID. I will say yes in this case. And what binding? I would like to use DB. For local development, do you want to connect the remote resource to local resource? That's a big no. Local development, I would like to connect to local resource. And that will be. If we're back here, we can see that our database was been added. Our project database is right here. Our database ID is right here. and the bindings here. That's actually pretty cool. That will allow us to start doing a particular application, but not completely there yet where we're supposed to. Because yes, we're declaring the binding here, but we are not initializing anything yet. We should be the reference and initialize that in our project in order to make it work. So one of the things that we need to do here is apply the specific migrations. The migrations are, and those are going to be created whenever we specify what something needs to be done on there. Whenever you query the database, you create a table or something, that's when that database actually will be created. And locally, when you run locally in your computer, that will be inside your Wrangler D1 folder. And we'll see that in a minute. But in order to make it work, we need to have a migration. What is a migration? We will generate a bunch of SQL files. Those SQL files, what we'll have or what we'll do will be pretty much to create the actual tables. So we can have something like create table called projects, and then we specify the different values like ID, integer, primary key, name, that everything that we saw already in the database class, and how to create specific tables. And one of the cool things about migration is that you can keep record about what is being changed to the database. That way you can create a table, you can add a column later, you can remove a column later. So those will be like SQL files that need to be run in a specific order. And in order to understand what needs to be executed or created, um, and also instead of doing SQL directly, we'll be using ORM that will help us doing that. An ORM is an object relation mapping that will convert or will define objects, in this case in JavaScript, that will reference a specific table and columns on our database. So we'll be mapping the database to an object in our code. And it's a better way to handle it because we can define that through JavaScript, the different schemas. And then whenever those schema changes, we can generate different migrations. So this is one of the best way to do that one. For this, we can go through the process, what we need to create or do. We will pretty much handle the SQLite one. But well, it's actually the Cloudflare, the one. And it gives you like a possible basic file structure, source, database, schemas, index, like pretty much what we need. And we need to install Drizzle RM, and we need to install the Drizzle kit. Drizzle kit will allow us to generate those migrations that we'll use later. And Drizzle RM is pretty much the old components that will be used to connect to our database person. I will show you that in a minute, what I'm talking about. Forget about .env, Wrangler, forget about TSX. Like those things go here. Let's just handle the Drizzle RM and the Drizzle kit. So let's do a simple npm install Drizzle RM. And I need to type it correctly. Cool. Oh, we have some vulnerabilities there that we probably need to fix. Okay, I will show you that in a minute. npm install, sorry, in development will be Drizzle kit. Okay, now we have more vulnerabilities. Okay, let's do a simple npm out just to see what we have behind. Hono a little bit, Wrangler is a little bit too. Let's do npm. I don't think update works here. Let's try it. Okay, yeah, we have for moderate. It's a lot better. with the npm out to see the outdated dependencies. We don't have anything outdated. We went back to for moderate. Let's do npm audit fix just to see what is there. It's because it's build kit, core drizzle kit. Yeah, that's actually fine because the issue with drizzle kit is just a development environment. Drizzle is not being installed in production reality. So I think we can move forward through this process. So it doesn't matter. Whenever we push this to production, drizzle kit will not be there because we make sure that drizzle kit is only a development dependency. Drizzle RM is the one to be using in production. So whenever we deploy the app, this is the things that are going to be running. All the other one is just for our computer. So I think that will be more than enough. Let's commit this. Let's say it added D1 and drizzle. Cool. And we can sync it. So let's go back. So one of the things to make drizzle work, drizzle need to have a configuration file that will define us how to connect or what to do about this. We already have a source data folder. Probably we can reuse that one. And we can interpret what need to be done in the different elements. Something that we can do to. So let's, in a root directory, we need to create a new file. And that one should call drizzle.config.js JavaScript file. And for this particular file, we just need to tell Drizzle what need to be created or what need to be doing. So we will to import define config from Drizzle kit. And then we export default from the define configuration. And then we tell what will be the configuration about the database. For this, we need to have a schema file. That schema will be located in source data. And let's call that schema.js. Doesn't exist yet, but it will be there. Let's do where that one should be out. Let's make those out inside the mm, data migrations. The migration will be right there in the same source data, and it will be a folder. And we need to define Drizzle can connect to different type of database, so we need to tell the use the a specific dialect, and the dialect will be, as you can see here, the use SQLite. And the last one, the driver, in order to know how to connect to a database, we'll be using D1 HTTP. And we save that. That will allow us to tell our Drizzle configuration what to do or where to see, where the schema should be located, where the output for the migration, and the dialect and the driver that we'll be using. So let's create the schema file right here, new file, schema, and that one will provide pretty much the definition of our database. We will define what tables do we want and how they want it to actually work. And then Drizzle will handle and create the SQL file that will map whatever object we created. So we will create a couple of objects to be doing those. For those, we need to import a couple of things from two different places. Drizzle provide different elements. So we need to import SQL from Drizzle ORM, and we need to import a bunch of things from rm / SQLite core in order to understand here. And here we'll be getting check. We need to have index, integer. We need to import SQLite table and text. So we will define our integer column or text column. In general, generate the SQLite table, which column will be an index, a check just to do a validation, because it's really important. We need to do validations everywhere where we do. So let's save those and start doing. So you can go through the documentation for the result, but let me show you a little bit what need to be done. So we need to export projects, and that will be the name inside or document in this case, and we'll see the project will be a SQL table. And then inside SQL table, we need to provide the name and then the columns. So the name will be projects, and then we can provide the specification about the columns. Something really important. This project is the name of the table. This project is the name of the object inside our project. So whenever we need to say something about the project table, we call it project. So just to have that distinction, this is the name of the table. This is the name that we doing through the object that will be called inside our code. That will be. And for this, we try to map it out what we already have here. So let me just get this one, copy, and we'll paste those here and comment those out. So we can actually remove this one too. So we need to have an ID. This is going to be our main index. So it will be the primary key. We have the name, that's text, description, that is text. Created at, that it will be the specific date. SQLite doesn't have date field, so we'll use text field for this. But they have already a function that will help us regarding those. So let's start mapping up our columns to this particular object that we'll be creating. So let's do ID. That's the name of the column. We'll say this will be an integer. And then we define the name of the column inside the table. So as similar as here, this one, the name of the table, the object, this is the name of the column, and how we'll reference that outside. As simple as that. So let's do integer. It will be primary key. And the cool thing, they have a property that we can define, the auto increment true. That way we don't need to handle any index. What is the next index that we need to have through here or through there? That will automatically define by us by the table in the auto increment, because we define the ID is the primary key. Then we can say the next will be the name. And for that, we'll just say the text. We'll call name. And we just need to define that this should not be a null object. Right? Description. It is an optional, but we're always saving at least an empty string, right? When it's not description. So we do description. Description will be text. Let's call the column description too. Let's say a not null also, but let's make a default of empty string. So here we're just defining, at least it's an empty string and it should not be non null. So we just warning this out, and we can have created at, and that will be another text. Should be created at. And let's make another copy here. This will be updated at, and here will be updated at. Now, what you can see different that I'm doing, the name of the table has underscore, it's a snake case, and the name of the object have Pascal case. It's just a way to handle that in a way, right? So this is the way that will be declaring our project folder or project column. Now we need to define our task ones, and that will be a little bit different than the projects, because remember now in SQL we need to provide the link between the two tables. We need to say what is going to be the reference, and the relationship is one to many. That means that one project can have many tasks, but one task only can have one project. And for doing that, we'll create another object. Let's export that one to come task. That will be another SQL table. And then we define the different columns. And let's go back to the store. Let's copy this one for the task, just to have it as a reference right here. And let's comment those out. We need to have the ID of the task, then the project ID, then title, description, status, created at, and updated at. Okay, I think it should be easy enough. So the ID will be really similar. Let's actually copy over the previous one. It's an integer. Let's call ID primary key and to increment. Then we have project ID, and that one will be a little bit different. Let's do integer, and that will be called project ID, and it should be not null, but it should be a reference, and we'll be define the reference in a function. That function doesn't get any input, and it will say it will go to our project's object dot ID. As you can see, all this that we defined it through here, you can see it here. So we see project ID. So we just make the reference there. And we can define comma on delete cascade. What does mean? When we remove a project, we will remove as a cascade every task that is defined or is targeted by that project by the project ID. So here just making that reference per se. Just making that this field in the task and table is reference the project ID table and do the on delete on the cascade, right? Then we have the title and description. That's pretty much the same as the name and description over here. Let's just change it and change this one to title, right? Then we have the other one is the status. That one should be a text. Let's call it status. And this status should be not null. That's important. And by default, let's make it the to-do one. Right? We will have an extra validation in a minute. And then created at the data that we can get it one to the top and paste it over here. And that will allow us to have the schema the way that we need it. But now, we'll do an extra validation just here in the task table. In order to prevent injection on other elements, I want to see that status should be only the status that we mentioned before, And I want to, whenever we push something with a project ID, that project ID already exists in the projects one. So to have an extra validation. For that, we can do a comma here. And whenever we have the different element, we can define extra config. So for that extra config, we can do a function. And that function should be doing something, right? For here, we will send a table. That will be your task table. And here we will tell, you know what? This actually is an array. I need to do a couple of stuff. First, I need to check. And that's why we import a check. That task status check. We provide a name to the check that we're going to be doing. And in this check, we need to tell something. We need to run a simple query, SQL query. That's why we import it. And the way to use it is with the back kit right here. And we define it right away. Or table dot status, because we're defining, like, we are referring the same object. So we say that the status of this table should be in, and we can do a simple, actually this should be inside here, should be in to do in progress and done. So we're doing a checking, and this is a simple validation. It will not allow to insert something if the status is not one of those three. That's pretty much what we're telling. But this is not the only checking that we need to do. We need to verify the index from other elements. So we need to make it a name. Let's call this index tags project ID. I need to take the index on table dot project ID. There you go. So we'll be checking and verifying the index exists in there. Well, that is our schema object. It looks a little complicated, probably, but when you start seeing what we're actually doing, we just define by code what needs to be done. Now, if we go to our package JSON, we can define a specific command called generate. We can do here, let's do db generate. That one, what we're going to do is we'll execute our drizzle kit. Generate. It will pretty much create the SQL files that belong to the schema. And we'll know how to do it because our configuration are already pointing to that what needs to be done. Right. So we will go back to our projects, to command prompt. We do npm run db generate. This should be done every time the schema change, just to make sure. The result key generate to tables, projects, and tasks. The SQL migration is in that. It give me a number and it give me a random name. It got acoustic plus in my case, SQL file. You go here, the migration folder. It has some metadata that we are not going to use in right now. But then we have the SQL file generated for us. And there you can see right there the constraints and the index and the tables created. This is actually pretty neat. So the cool thing here is that we need to handle any SQL file anymore, at least not for this project in this part. Whenever something changes and we need to add like a table, we change your schema, we generate again, and new SQL file will be created for us. And those will provide the different um, things that need to be created. Okay. Now we need to let know Wrangler to actually to use that migration. For that, there is a command that we can actually look here too. If I look for migration, oh no, this one, um, migrations for D1. We can define on the, where is it? Wrangler customization, we need migration folder, your worker directory, and then we have D1 migrations. In order to run it, we can have migrations table, migration directory. So probably we need to define the migration directory. Let's try to run it without it. If not, we need to provide it through here. But let's try how it actually works. And it's with a command called, I was thinking looking at here, but I don't see it. Is the D1, is the Wrangler D1 migration itself. So we should be able to do simple Wrangler D1 migrations, apply, and we need to name our database. Our database is called projectsdb. Apply projectsdb, and we define where we need to apply those. First, let's actually run it locally. Local. We click enter. Yeah. We need to use remote if we want to do it, but we have an error because it didn't find the migration folder because we put it in a specific direction. So let's define that in our Wrangler JSON. So let's go back to the result configuration. Let's take the out, the migration where they are. And here we can define comma migration directory. It will be this one. We'll save it. And we can run the command one more time. It says in found one migration. That's the file that we had it. Those migration, whenever we add more elements, you will see that you have 000, 001, and it will execute those in that particular order. So right now it's telling me, we found something. Your database might not be available to serve requests for the migration. That's okay. So I say yes, apply it. For command secured successfully, and the database was created. Okay, this is just the local database. That's really important. If we want to generate the migration on Cloudflare, we need to do a remote flag. I don't think we're going to be doing that in this video. So going back here, I want to showcase that we should be having that here in state. We have the D1 folder, and the first file is our SQLite file. We don't have a SQLite viewer, so I think we can install it. We look for SQLite. We can use this one, the viewer. At the time of the video, it has like almost 3 million installation. Let's install it. Trust. Okay. Let's put it over here. You can see there. Cool. So it created a migration folder. It created a metadata. Okay, but you can see right here we have our projects table, ID, name, description, created at, updated at, and we have our task table, ID, project, title, description, status, created, and updated. Pretty neat, right? We can see it actually is out there. Now, important. Our project has already this folder to be excluded from our GitHub repository for a reason. That means that we're not updating or pushing our database to our GitHub repository. That's really, really important. But now we can see that this actually works. So let's do this. D1 migration done. Boom. Let's provide them to have the connections to the database per se and start using those right away. So the way that I'm thinking here that we should be proceeding is inside our data, we have a schema we store. Let's make a way to actually connect to the database first. And then I would like to probably create two repositories file. One repository will be for projects, another repository will be for tasks. And we will mimic the same names or the same elements that we have in the store. The list project, get project by ID, create project, we will mimic those, and now we'll be using Drizzle to connect to the database and execute those the way that we need it. So the first thing that we need to add here in our data, our database.json file, because we need to find import like the migration generate just to create a table and create a database in this case. But now we need to get a way to actually connect toward that one through our code. Right now, we not executing code or our project is not actually connecting to the database. For that, we need to import Drizzle from, and Drizzle again has a lot of element. Let's do D1 and let's import everything as a schema from the schema file. And we can say something as simple export function get database, and we need to provide a connection, and we will define that in a minute. And for that connection, we just need to return our Drizzle. I don't know what I did here. Okay, Drizzle, and the Drizzle we need to have a client. There will be a miniflare D1 database, that's the type, and a configuration. So here we just need to, the client will be the connection that we'll provide, and the configuration will be the schema that will re-import in order to understand and know how to map it out, right? And here, now that I'm here, I will actually just export to the function. Now ISO, the one that we had before, and that will just return new date to ISO string. Cool. That will be our connect. Let's now create a new file. Let's call this projects dot repository dot javascript is our data layer, and for that we need to import we'll be using ascendant and equal from Drizzle ORM. We'll be using no ISO from DB, and we'll be using project from schema in order to understand what wanted to be done. Right? So the first thing, um, let's do every interaction with the database should be an asynchronous interaction because those actually could take time to actual process. So if I need to have export asynchronous function, list projects, and we'll be sending the DB that we need, and we just say return db.select dot from projects dot order by ascendant by projects ID. So whenever we call the list project, that we're just doing our database that will be provided. We'll do a selection for the projects table, and this is the name of the particular table, and order by ascendant is a SQL wrapper by projects ID. Right? We can see the project has ID there in the name. We can see it through here. And now with that, we can actually just move forward and add the rest. Let me, no, let's do it manually. I was about to copy over all those, but let's do manually. And that will be mimic the list projects. Let's do now the get project by ID. For that one will be pretty much the same. Export, oops. Export asynchronous function called get project by ID. And here we'll be providing the database that we need to connect and the particular ID. And for that, we need to const verify if the project exists. And we'll do await dot db dot select from project where, and then we put the equal element here. Projects dot ID with the ID provided in this function. Now, every select provides an array. But here we know that this array should provide only one. That's why we are having the naming convention of project in order to make only one value. And that will allow us, the way that we have it in the store, that we return the project, a clone of the project because we were doing the reference in the memory, or null object. We don't need to do any cloning anymore. So here we just do a simple return project, or if project doesn't exist, return null instead not doing undefined, right? Now let's do create project. That one will be create project. We need to provide database and the input. Timestamp will be now ISO in order to get the current date. We need to normalize the input, and we'll show you that in a minute. And created at timestamp. Updated at will be the timestamp, and then we'll see, well, created will be a await database insert. In projects, the values that we created through here. And when we say returning, that means that we need to have that one coming back in our element. And then just return whatever we created. For the normalized project, what I want to have is a simple local function, and let's put that at the top. This what it does is everything object that has name, it will provide the name trimmed, and description will be the trimmed or empty string, just to have the sanitation across the board. That's it. And it will help us also to, if we send something that is not required, that will get away. Because for project input, I just need name and description, and that's it. So they will also help us have that validation. So we're doing validation in several places. They will allow us to help us prevent any type of SQL injection in our project. Okay. So now that we have the create project, we need to update that particular project. And for that, we need to provide the ID and the input, the values that we're going to be updating, right? We always send it the database to connection. So we create the values object with updated at will be the new now ISO because that's the new updated. And then we provide well name. If this one has name, it will be the name trimmed or nothing. If it has description, it should be description trimmed or nothing. And then we say, okay, const updated will be await update from project set values where the project ID is equal to the ID provided here. And returning is get the value back. Is updated exists, return that or return a null object. And last one will be delete project. Will be provide the ID and the database, and will be a simple await from the database delete from that folder, from that table, where project ID equal project ID. And we just return in that particular project ID per se. And that's it. And return delete length equals 0. So this will help us to our repository and to actually have the connections to database that we needed. This will allow us in our route, instead of using the store, actually use the repository. So let's remove, let's actually, we keep create tasks from here for now. No, actually, let's remove those. So for this, in order to make it work, let's remove list project. Let's remove get project by ID, create project, update project, update project, right? We have a bunch of errors because here Lean's finding that we're making declaration of function that doesn't exist. That will help us validate a little bit. So I can do now is import from, let's say, would be data project repository. And I need to have my list projects. I need to have my create project, update project, delete project, and get project by ID. The other things that we need to create or have to is to actually get the actually database per se. Now for the database, we can do a simple import from DB. We need to import, I think we call it get database. Oh, so that will allow us to do a couple of things. We're almost there. When we list the projects, we need to send the database. We are not sending anything. So we need to fix that. And this actually changed a little bit. So whenever we get the projects root, this will be an asynchronous now, because now we have an interaction with the database. And we can do a simple const database equal get db. And remember that we need to provide the connection. Well, Hono Wrangler will provide that as a environmental variable. So we can have our context dot env dot db, and that's the binding name. And with that binding, we can reference the database that we're connecting. So we just get the database to the binding, and we can do const data equal await list project, and we send the database. And when send the collection see data. As simple as that, because we will reuse the rest of the elements. So for the next one, we will be here before create project. Create project requires now the database and the input. So we have the input, that's the payload. But let's take the database through here. And we just do await. It was already, the post was already asynchronous, that's cool. So we just do await, create project, and we send database payload. And that's a good way to do it, because if we need to change the database connection, we can provide a new one. The next one will be forget the task. We don't have the task part yet, but we have the actually get project by ID. That's the one that need to change. So we need to provide the database through here. And then this actually should be asynchronous now. And this one should be await. And we need to send the database and the project ID. Then for the post, whenever we do this, it's going to be really similar. This was already asynchronous, that's good. So we just need to call the database, and it will be asynchronous. Get project by await, actually. Await, get project by ID, and within the database and the project ID. Right? I hope that you're following me what we actually doing. Getting the database and sending the database. That's pretty much. And we're keeping the scope locally only when it's needed. And that's it. The next one will be whenever we post the what is the other one? Mm, Oh, yeah, we did this one for the post. Project get project by ID. Yes. Here we have the validation error. Create task, project ID, payload. We are fine for now. The next one will be here. Get the project by ID. That will be here. That will be asynchronous. And this should be await. Oops, no. Here, await. And we need to send the database and the actual ID. And this is not create database, get DB. Cool. Whenever we patch it, that also need to happen. And it will be right here. We need to copy the get the database We just need to make sure that every call dependency, it should be added here. Wait, object project by ID. It came now from, we know that came, if we do command or control the name, it came for the repository. So we're coming where it's supposed to. Cool. And we need to send the database, the ID, and the input. So we need to send the database, ID, and the input that is promoted payload. For last one, I think it will be the delete. And this one will be right here. This will be asynchronous also. And this should be await. Oops, no, not that one, this one. Await. And we need to provide their database and the ID %. And I think that should be enough, at least for the project side. Let's try to run it and let's try to test it. Let's do npm run dev. We can see right there, we have env database, that is project database as resource. This have a binding. We have mode local. That's actually cool. And it's right now running in here. So look like everything is executing the way it's supposed to. Let's try this. So we can get all the projects. Within that should be empty now. Our database doesn't have any project at all, right? So let's post a project, create project to API projects, cool, body, new project, hello there. Let's send it and let's see what happened. Ooh, we have an issue here. Let's see what we did wrong. I did wrong in description, created out updated values null. See, no, null description, parameters new project. Okay, we have an issue that should be fixed. So let's see. There's a failed query insert into project. Name and description, created at, updated at, values null. Somehow the values are not being. Actually, ID should be auto incremental. And this should be the timestamps that we're calling off. So something is having an issue here. Let's see if we can troubleshoot that. So let's see what's happening. So somehow the timestamp is not being generated within now ISO. Let's see how we had it here. Yeah, no, ISO is the return new date to ISO string. And that should be through here. And that came from our database, right? Database export no ISO, new date to ISO string. Yeah, I think it should be the same. We can troubleshoot that in a repository. Let's do a simple console.error to have it there. And let's do the timestamp. We save it. This should be running, reloading. Cool. So we should be able to push it one more time. Let's see what is the error that we have now. Okay. Timestamp is there. So somehow this is not being worked. So we can see here, we send the timestamp in ISO string, but somehow this one is not getting it through here. That's interesting. Let me get back to my repository. Let's do console.error values. Let's actually do the values like this. And they should give me an object. This already restarted. Cool. And if we send it one more time, okay, new project hello there, created at and updated at. It's actually working. I can see it through, I can see it right there. Okay, I can see the object being created correctly, but somehow it's not being sent correctly. Let's see what else we need to have here. We have asynchronous, and we are waiting insert projects, values from our values. Interesting. So somehow this is the one that is failing. Let's see what we can do about it. So if you're looking at this, so I know that the value has been sent, but I found it, that's what is important. Let's read the error. Failed to insert name, description, value, empties, and then we can see parameter new project, and then we can see parameter. The second parameter is actually empty, and this is a problem. That means that this description somehow is not being sent through here. So let's look at the schema. I found the issue. I have a typo. So our database is looking for description, not description. So let's actually, it's really funny. Let's have this description, save it. That's why it was not working. Let's close the server. We need to do npm from db generate. We change our schema. We can see now the migrations is description. Okay. We can do the Granular D1 migration in the local environment. Actually, you know what? Let's copy this and let's create in the package JSON what is supposed to go there. And let's do generate. Let's do db migrate local. And let's do remote the same, but remote. We have the migrate local, migrate remote. Okay, but we'll be using database migrate local. Let's look our database before we actually do that. That one is here, state D1. Database right here. Project. Oh, you say description. It's actually say description because the schema, where is the schema? File. Okay, yeah, because this one is actually correct. The issue, so we don't need to do the migration actually, because the database didn't change. What changed is how my object was called through here. So a simple typo, we need to be really careful. So let me cancel this, Control C, clear, npm, run dev. Okay, running one more time. Let me go to my project repository. Let me remove my console logs that I don't need anymore. Save it, and let's try to run it. So we get all the projects, should still be empty. Create project, should work now. I have another issue. What is now the issue? Okay, we can see the parameters are there. Created at. Created at. Well, we're sending in created at. Oh, it's actually called like this. We need to be really careful. This is updated at because we're using Pascal case here. Okay. Reloading. Perfect. One more time. Create project. Send. There you go. New project was being created. Let me get all the project. We should have meta count 1. There you go. Cool. Now it's working. If I get projects 1, it should work. Yeah, it's doing the data. If I do project 10, it should give me 404. Not found. Cool. If I patch the project 1, let me send that without description. Instead of first one, let's do first project. And let's send that. Okay, we go change it. And when we call it, it's right there. Pretty cool. If we get back to our database file just to see it, we can see that here we do a simple refresh. Our first project is actually there. How cool is this? Right? Let's save this, added projects DB, and let's just add one more file, and that will be our task repository. And let's make this a little faster, but I think it's already a long video. Data, new file, task repository JavaScript. And for this, we'll be sending all this. So we importing the no ISO, the task, ascendant equal, normalize task create input from project ID and input. We need to return the project ID. And this one actually being called inner schema, a little bit different. So let's actually open the schema on the right side. So project ID is called like this. Cool. Created at is called like this. Updated at is called like this. Okay. Well, he put it normalize. In the project we did the normalize, we send it in here. So it, could be one or the other. Both actually works in this case. And for this one, we say the project ID is this one. And we're just telling get the database project, return database select from task that we imported. Now we are reference the task table where task project ID is equal to the project ID provided and ordered by task IDs. Cool. Let me minimize this. Okay, everything looks good so far. Here, updated at change to this one. Title, description. We have the correct description. Yes, we do. Cool. And that should be it, I think. Delete task. We go all the way it's supposed to. So here we're just doing the same normalize, list project, task by project, get task by task ID, create task, update task, and delete task. Pretty much. That should allow us to go to the projects endpoint and create tasks and list tasks by project will not be from store anymore. This actually will come from the project from the task repository. And now we need to see the create task, where is it actually located? Right here. We need to send the database first. So the cool thing about that is we already have the database right here. So we can just send database, project ID, and the payload. That should work. And that was the only place that was mentioned, I think so. Let me look for that. Is find 2 times, perfect. And let's look for this. You find 2 times. So here we just need to send the database that we already called here, but we just need to provide that one right here in order to make it work. Cool. Now for task, will be something really, really similar. We need to, instead of store, we will get this from our task repository. We need to import get db from database file. Cool. And then we just need to look for delete task. Can we see where is it? Right here. So this will be asynchronous. It should be await. And we need to call the getDB in order to send it here. Let's look for get task by ID. It's just right here. That means that we need to send our database or binding. And we have it through here. This will be asynchronous now. And this will be await. And we need to send the database first and then the ID. And last one will be the update. That just appears once. It's 2 here. Cool. And that one should be also, it's already asynchronous. Oops. What I'm doing? Sorry, there you go. No. Let me get the database one more time. We get the database. Cool. We do await. And we just need to send this over here. And that should be it. So our patch is asynchronous, our delete is asynchronous, and our get is asynchronous. All of them are getting the database per se. So saving those elements, our project got reloaded. We should be able now even to remove the store because we should not be needing this anymore. We're using the repositories now. If you go to get task by project ID, there's nothing here. That means that we should be able to create task to project one. Cool. Body. I'm going to send that one as a JSON. And let's do title. First task. Description from API. If we send that, we have an issue here. You've got empty data. Let's see what happened. API project one task. It says created. Oh, you got created, but we're not sending anything. Interesting. Let's see. What about the header? Oh, that's undefined. We need to change that because the header is not there either. So let's see the header for create project. That one was fine, but not the one for task. Okay, let's check that one. For now, with your database task, the task was created, so it should be there and to do by default. Yeah. So that means our issue is the way the task is being called. So that one is actually here. So we created this one. Okay. Length. Okay. Task. Oh, here. This is the issue. Create task should be await. It didn't await. That's why I have an issue. That should be it. Let me see how many times it appears. Okay. And list tasks by project. This should be await. Or database interactions are synchronous. So in order to send that data, we need to await. That means that, oops, right here. When we did get task by project ID was given empty, it should work now. And the counting, let's create another one. Second task to the same project. We can see the location is actually working now. Cool. And we have the data here the way it's supposed to, status to do. Perfect. We can now get the task by project. All the two are there. Excellent. That means we can actually delete a task. Let's delete the first one. Okay, no content. That means it works. And this one should be only getting the second one. Yep, I think everything is there. If we delete the project, our database should be empty. And the cascade should happen. Or let's refresh. Yep. We don't have projects and tasks because when we delete the project, it deleted every task that was already defined there. So I think that will make it for now. Let's commit everything and add it as DB. So there's a couple of things that we need to be aware. We're able to create the D1 database. We are handling locally right now. We use Drizzle as ORM or ORM. Sorry, my pronunciation is not good right now. In order to connect to the database, we were actually created the migration. We use Wrangler for the migration, but we created the migration with Drizzle. And then we use Drizzle to actually connect to the different tables and do the updates, changes that need to happen across the board. Be really careful about your typos. Use our mine right here. You need to be really careful about awaiting for the data. This is asynchronous. We have now interaction with the database. And that should be it. Next video, I think we need to handle now authentication, the way that we can now push it to production somehow. Other than that, I think that will be it. I hope that you like it. Any question, any doubt? Don't hesitate to reach me. Happy coding, everybody.